Welcome back to the podcast. Today we're diving into a fascinating new paper, ECG-ResViT, a hybrid CNN-ViT model for efficient ECG signal classification.
Oh, that sounds super important. ECGs are, electrocardiograms, vital for checking our heart health. What's this paper all about, essentially?
Well, it tackles a big problem, accurately detecting serious heart conditions like arrhythmia or congestive heart failure using ECG signals. Manual analysis can be tricky and time consuming.
Right. And with so many people affected by heart disease globally, faster and more reliable diagnosis would be a game changer for sure.
Absolutely. The paper proposes a new AI model, ECG-ResViT, that combines two powerful deep learning techniques, convolutional neural networks, or CNNs, and vision transformers, ViTs.
Okay, so a hybrid approach. I've heard of CNNs being great for image recognition, but how do they help with squiggly ECG lines?
Good question. CNNs are excellent at finding local patterns, like specific P waves or QRS complexes in an ECG. They are good for fine grained details.
Got it. So they can pick out the small, important features. But what's the limitation there then?
Their main limitation is struggling to capture long range temporal dependencies. They don't always see the bigger picture across the entire ECG signal.
Ah, that's where the vision transformers or ViTs come in, I'm guessing, for that bigger picture view.
Exactly. ViTs are known for modeling global relationships, seeing how different parts of a sequence relate to each other. They are great for long term patterns.
So the ECG ResViT model is basically getting the best of both worlds, CNNs for the details and ViTs for the overall context.
Precisely. It's designed to overcome the individual weaknesses of each. The CNN extracts local features, and the ViT then models the global dependencies.
That sounds incredibly smart. How do they prepare the ECG data for this? Before feeding it into the model.
First, they pre process the raw ECG signals. They segment them into smaller fixed length chunks, like 500 data points each.
So breaking a long signal into manageable, consistent pieces. That makes sense for computer processing, right?
Yes, exactly. Then, in the CNN part, they use special techniques called residual blocks and dilated convolutions to enhance feature extraction.
Residual blocks aren't those for helping very deep networks learn better and avoid forgetting earlier information?
Spot on. And dilated convolutions allow the CNN to capture features at multiple timescales without significantly increasing computational cost. Very efficient.
Clever. So the CNN extracts all these rich local features. What happens when it passes to the VIT part?
The ViT adapts to the 1D ECG signals. It converts the CNN's output into a sequence of embeddings and adds positional encodings to preserve the timing information.
Positional encodings. So it knows the order of the heartbeats, not just that they exist. That's crucial for diagnosis.
Absolutely. Then, the ViT's multi head attention mechanism really shines, capturing those complex, long range temporal patterns across the entire ECG.
Wow, that's a comprehensive approach. So what kind of performance did this ECG ResViT model achieve in their tests?
The results are truly impressive. It achieved an accuracy of 99.13% and an ROC AUC of 99.94% on benchmark datasets for ARR, CHF, and NSR.
Nearly 100% accuracy? That's incredible. It means fewer misdiagnoses and quicker treatment for patients, potentially saving lives.
It really does. The model significantly outperformed several existing state of the art methods, demonstrating the power of this hybrid architecture.
So, this ECG ResViT isn't just accurate, it's also efficient and interpretable, making it a strong candidate for real-time clinical use. That's a huge leap for healthcare AI. 4.